Hello there, everybody. My name is Benjamin Collins, an applications engineer with MCAD Technologies, and this presentation is going to be to recover some of the details of our Tech Days 2015 and to look at the new product from SolidWorks, which is called SolidWorks Model-Based Definition, all about 3D product definition. But to start us off, let's talk about how things can get a little lost in translation sometime. And this is just a favorite joke of mine, but it starts out with a young German officer in the Coast Guard. It's his first day on the job manning the radios. And soon after he sits down, a call comes in, and a ship reports in English in distress that they say, "Help, help, we're sinking. I repeat, we're sinking, we're sinking." And the young German officer, speaking very little English, responds back and he says, "Hello, this is the German Coast Guard. What are you thinking about?" Obviously, losing something in translation there, maybe not being as helpful as we were hoping for. This happens in other places. We put it into Google Translate, doesn't come quite out like we expected. Flushing twice to save water, and so on. But this also happens to us in the world of engineering, where we go from our 3D modeling environment through a 2D CAD software and then up into our 3D manufacturing environment. And the translation between these can be very different. And as we all know, it takes a lot of time in rework and drawings, and where the drawing doesn't match and we have to send it back, and this is just kind of a pain, right? So let's talk about we're going to answer the who, what, when, where, why of model-based definition, but let's start out with the why of model-based definition. Now, MBD, as it's kind of colloquially known, is more of the process name, although it's also the product name for SolidWorks. And let's talk about it for a minute of why we need this product. And what we're going to kind of answer is that your business, you can think of the money coming through it as a flow, right? From your revenue and your sales into your liquid assets, your current holdings, a tank, right? And you have your outflow of your R&D, your production equipment, etc. Well, all these reworks, this scrap, this drawing recreation, revision control, all of this extra stuff, they're all leaks in your business model, and that means that there's less flow coming out the other side, there's less liquid asset being able to be used on the fly. The DoD, and we're going to hear a lot about the DoD, did a series of research grants on this subject, and found that a third of all engineering dollars are spent on 2D drawings, and yet 60% of them don't even match their 3D models. This is a lot of rework being done. So the fewer leaks we can get in this setup here means the more production and revenue we can generate down the line. All right. So we just answered a bit about the why. We're going to come back to why near the end, but let's also answer the rest of our main questions, right? And let's start out with what is SolidWorks model-based definition. So model-based definition as a whole, as I said, is the process of defining your product digitally in 3D, making sure that the 3D file, the CAD file that we generated the part in, has all of the dimensioning information in it, rather than having to create a 2D drawing. So in this way we can capture all of our product information and have fewer files to manage. And the ultimate goal, as I mentioned briefly, is to replace, or at least vastly displace, 2D drawings in your current production scheme. It's a lofty goal, but I think you'll see that model-based definition, if not now, but soon, will be easily able to take on that demand. So again, defining your products in 3D, having a fewer files to manage, and replacing our 2D drawings so that we have all of our information in our 3D model and we're not getting so much crosstalk, right? Well, let's talk about how to use SolidWorks model-based definition. You're saying, okay, Ben, SolidWorks is coming out with another new product. I'm going to have to learn a whole nother interface. What's going on here? Well, the benefit is that this software is very easy. If you're using the 2D drawing software from SolidWorks already, you're going to find that the controls are very similar and intuitive. All right. There's going to be some auto-dimensioning schemes that are going to give us the ability to dimension our parts initially. We're going to be able to take advantage of 3D sections that we can make in our parts already, but take advantage of those as part of our views for our 3D parts, right, that we would have in our 2D drawings. And we're also, of course, going to be able to attach our GD&T annotations, and you're going to see that it actually has some intelligence built in around those GD&T annotations to make sure that we get everything dimensioned properly. So let's go take a look at the software and see what we got going on here. We've got this gear plate assembly, and this centerpiece in the middle here is the piece we're going to be looking at and dimensioning today. All right. If you're unfamiliar with some of the changes in 2015, I highly recommend looking through it, but one of my favorites here is this open part in position. So just left-clicking on the part, I get my pop-up menu, and using this open in position, I can open the gear plate assembly itself in that same position it was in when I had the assembly rotated there. So I've got this part, and we want to go ahead and dimension it. Now if I were to make a 2D drawing of this, right, you can go ahead and make a part drawing, let's say out of a B-size template. It's a relatively complex part, and so it may be that placing the standard three views is just not enough to fully define this part, right? We can see here that some of the accuracy is getting messed up, our display settings are a little weird, right? And we'd really like to be able to capture all this a little more easily. We might need additional views to be able to capture everything, which is pretty common in 2D drawings and is the same for model-based definition, but you know, those additional sheets, getting all those dimensions arranged, can be kind of a pain. So let's take a look at what model-based definition is going to offer for us in replacement of this, all right? So right now, model-based definition is an add-in for SolidWorks. It's consumed on the install. That licensing structure will probably change with the 2016 release. And we will also see the addition of a professional and a premium version of SolidWorks model-based definition. So what you're seeing today is just the basic version, the standard version. All right. We're going to take a look, and just like every other add-in, it's just a tab here on your command manager. And across the top, we'll come up to the Dimension Expert. So it's built on this tool that's already been in SolidWorks a while, the Dim Expert, and it gives us a couple of extra tools. So in kind of the simplest fashion, we can apply our datums, right? If we're already designing with datums in mind, this will help us out a lot in being able to define where we want to put things and how we want to dimension the part. And you'll see here I'm just clicking on the 3D geometry that I want to use to define my part. And so here I'll throw in a couple of datums to give us some definition here. And I'm just kind of placing these down. You know, obviously it obviously depends on what the exact specifications of your part is, you know, where this gear assembly has to fit in, so on and so forth. But we can take a look, and let's say I grab a location dimension. This is going to be, like it says, location, but check it out. We've got a Smart Dimension tool on our icon here. And I can just click on a face, click on another face, and pull a dimension out in 3D. And pivot around to see what that value looks like, right? Now I can continue placing location dimensions, so maybe let's get a depth here from this face all the way over to the back. And we'll also get some controls about the size of these holes, which instead of being a location dimension is going to be a size dimension. So I can grab a size dimension, simply click on a hole, right? And it's going to pull out the size, which is great. Or if I'm using a hole wizard, which I strongly recommend for any kind of standard holes that you're going to put a fastener through, just so we get our standard sizing, you see that it actually pulls out the hole count as well as all the information needed to drill that hole. And I have the ability here to check whether or not I want it to count the instances. And of course I can type in extra values underneath here in the text box to add on to that list. So this is great. We've got a couple of dimensions on here. They're all in 3D. We can see what they're pointing to, which is incredibly helpful to be able to understand the model. And but of course the question always comes up, you know, it needs to be answered of what happens with our geometric tolerancing. Just like in your 2D software, we're going to create the geometric tolerancing feature using this little wizard here. And notice I'm placing spaces in here to just kind of have everything be a little better lined up. That is just for the 2015 version. SolidWorks tells us that they are going to fix that for the 2016 version so that this spacing is going to work out a lot better. But for the moment, you know, I just placed that in here. And just like in the 2D software, if I actually click on a dimension, it will attach the GD&T symbol to that dimension. We can see it here, right? Now, I mentioned some intelligence in that GD&T symbol. Notice I have all three datums referenced in this GD&T symbol. If I were to accidentally remove or say originally define that GD&T symbol, and I had yet to put a C datum in, check it out. I get the gold missing relations icon, and I also get a rebuild error that shows here in my dim expert. And it tells me that either there, or if I double click on the GD&T symbol itself, I also get a warning that says, hey, datum C has not been defined. So you can't use that yet, right? Well, maybe I just accidentally deleted it. So I could go ahead and simply fill in datum C, reattach it, and the software is going to recognize that there is now in fact a datum C and that this GD&T symbol is okay. In fact, SolidWorks model-based definition has about 100 different GD&T checks it will do just to make sure that we're not dimensioning our parts in a way that doesn't make sense. It's always nice to not have a shoe thrown at us by our machinists, right? Well, let's also check out some of the additional features that are going on here. I'm going to get rid of these dimensions that I've created just to kind of show some extra functionality here. So I can go ahead and delete all these. Notice I'm here on the Dimension Expert panel. And I'm operating on a similar like feature tree environment where I'm getting rid of and manipulating particular values, you know, kind of in that same tree setup that we're used to. We're going to take a look at the auto dimensioning scheme here. Notice we have controls for prismatic and turned parts, as well as different geometric tolerancing types. Just as before, I'll select my datums, so I'll say let's make a primary datum here, we'll make a secondary datum here. Take notice of my cursor when I select this. If I don't move around too much and I make a right click, it'll actually move down to the tertiary datum as well so that I can select that easily. So in this case I can grab those three datums, or in fact let's take it and make it a depth datum here. So we'll take it like this. All right. Notice I can take this through all features as well, so I can have it dimension everything if I want to based on planes, surfaces, cones, the whole 9 yards. But as you might imagine, that gets a little messy. So let's dimension just a couple of features at a time. So I can select this feature, this one here, let's take this edge here. We'll grab this fillet over here as well as this feature. And for good measure, we'll pull in this circular pattern as well. I'll go ahead and auto dimension. What it's going to do is place the datums, all of the dimensions that I specified, as well as some basic geometric tolerancing info that's based off of, you know, some settings I already created. And you notice here that with certain dimensions where it's already attached, it attaches the C datum or the various datums to those values. We have the B datum here, right? And if you're wondering, it's turned the part a couple of different colors. It'll turn it from whatever the original part color is to yellow and also to green. And what this is the show tolerance status option. And what it's attempting to define, as you see here, is whether or not that face has been fully constrained. So referencing this face here, we have a height dimension, right? We have some other dimensions to it, right, based off of our datums. And it's saying that this face here has been fully located. So it's giving us immediate feedback on the quality of our dimensions. This is really handy. But you notice there are a lot of dimensions going on here, and it's very easy that, especially after I get a few more, maybe I stick in that depth dimension that we had before, right? that this can get a little crowded after a while and kind of difficult to read. So they have a couple of different tools for navigating this problem. The first one is what's called dynamic annotation views. If I turn this on, like a magician, everything goes away until I pivot the part into the relevant plane, and then we can see that the dimensions for just that plane appear. So if I can pivot to the side here, or to the side over here, and just get particular dimensions showing, right? This is incredibly handy to be able to navigate your models and make sure that you're getting your, some good information out of them. What we're also going to be able to do is take these different annotations here and arrange them into annotation views. So notice I have a right, a front, a top, a back, a left, a bottom, right? I can right-click and insert multiple annotation views. So I can even make this so that I have multiple annotation views pointing in the same direction, right? So just using the annotation creation wizard here, I'm creating another front plane, and I'm going to grab just a couple of dimensions like this whole wizard feature here. And let's also grab this diameter feature here, as well as this feature, right? You can see it collects all those various things. I'll say OK. And now what's going to be happening is that in my front view, those dimensions are no longer visible. But if I pivot to my second front view and hide the first one, I just get the 3 dimensions I selected. So by organizing these into annotation views, we can hide and show certain values to be able to see what's going on. Well, this is all well and good. And we're going to talk about some more capability here in a minute. The problem that arises out of this is now we have to double-click and switch between these. SolidWorks model-based definition has an answer for that too, but let's get to that in just a second. We're going to talk about some additional support for SolidWorks model-based definition. You may have been asking yourself, okay, Ben, I've already got this part dimensioned. Why am I dimensioning it again? Maybe I'm using model items import from my 2D drawings. Well, SolidWorks model-based definition has the ability to import your existing dimensions. If you have your Instant 3D turned on here on your Features tab, you can simply select the model and show various controlling dimensions for it. And then right-clicking on them, you can select an annotation view for them to be a part of. And then, showing that annotation view, I get only things showing on the right-hand plane, right? So I can reuse those annotations that I had before. But the advantage of using these pink ones, these dim expert ones, is that not only do they, can we set them off of different datums that maybe the part was built off of and set up our own dimensioning schemes, but SolidWorks model-based definition can actually also support your legacy data. So what I'm going to do here is open up just a simple part I have saved out in a Parasolid format. By the way, if you're exporting or importing into SolidWorks and you plan to have it kind of come back to SolidWorks, if you can play in Parasolid, that's the native format. It's a direct read. You'll have fewer repair errors coming back and forth between formats. But notice here I just pulled in this I-beam. It's imported geometry. I'll go ahead and take a location dimension, and just like I had designed it in SolidWorks to begin with, I can pull a dimension off of it and get ready to go, right? Well, if we're looking at this I-beam specifically, long parts like this that are kind of the same down one axis, I don't really need to be able to display all 12 feet or 75 inches of this, right? Because I can simply report what the cross-section looks like and how much I need of it, right? So sometimes we often use a break view in a 2D drawing to show, okay, this is what it looks like, but we don't need to show all of it. Well, model-based definition supports what we call 3D break views, or model break views, right? Where I can set how far apart these planes are, right? Set the angles that they're showing, and also simply come over here to the styles and be able to actually show, like in a drawing, a zigzag break to demonstrate that this is a shortened version of the part, right? You'll notice here that the dimension seems like it's not attached anymore. That can be fixed simply with a rebuild. So I just hit Control B, or you can hit the stoplight up at the top, and that'll rebuild and attach it. And so you can see it's reporting the correct value even though there's a break across the model. But if we take a look at this as well, I mentioned earlier the need to create section views, right? And cutaway views. Well, in SolidWorks 2014 and below, again, this is going to be a 2015 new feature. In 2014 and below, we could section along a plane, and that was great. We could take kind of our MRI scan of our part, right? Sliding the plane up and down. We could also section along multiple planes, so up to 3 different planes, cutting the part into, you know, fourths and then eighths, and so on. But the disadvantage of doing this was that by sectioning in this fashion, we end up with a piece of angle iron, right? This isn't an I-beam anymore. And it's kind of hard to tell what we're trying to show, potentially. So in 2015, they introduced a new tool, which they call the zonal section. Now, if you imagine the interaction of 3 different planes, what it's going to do is create different volumes. So in this case, we have 8 different volumes defined by the interaction of 3 different planes. Obviously, 2 planes is going to produce 4 different volumes. 1 plane is 2 volumes. And we can select here in the zonal plane selection which volumes to remove from the model. So in this fashion, I can be a little more precise about what pieces I want to get rid of. If any of you have been to an air museum and seen where they cut the quarter out of the case off of a turbine to show the blades on the interior, but leave the interior components intact. This is kind of the same idea, but virtually, so that we can show these things. All right, so I've got these views, but you know, these aren't necessarily permanent and all this kind of stuff. So what we'd like to be able to do is organize all this information into a more useful setting. As I already showed on this example, we had the ability to organize our dimensions into particular annotation views so that we can kind of keep things from getting cluttered. But if I may, I'm going to pull a little cooking show maneuver here on you and walk over to the oven. And let's take a look at a more complete example that's a little further along, right? So we take a look at this one, and it's got a lot of dimensions showing. We can look at the dynamic annotations view to clean that up a little bit and just be able to see particular dimensions from particular angles. This by itself is pretty handy, but let's also take a look at what SolidWorks model-based definition gives us in the form of 3D views. If we look at the bottom of our page here, I can see another tab, 3D views. And what this is just like on your 2D drawing, you're going to have a view from a particular angle showing particular dimensions. So in this case, I've pivoted to the top view, and I'm showing just the dimensions that were selected in the top view annotation. The advantage of this, of course, is that it's still a 3D part, so if I'm unclear about what those dimensions are attached to, I can pivot the model over and get some more information about it. In this case, you can even see that the dimensions are going to pivot so that I can see what's going on, right? I don't have to read them upside down. And the advantage of having, in our example here where we created multiple front views, in this case I've got dimensions more locating the general geometry, how far up this hole is, whether it's centered, how big it is, so on. But I can have another view facing to the front that details these flange holes specifically, so I can see those by themselves. Not have to be confused by overwhelmed by the extra data points. Here again, I have a little bit of a check on this pattern here, just saying, hey, something's up here. Probably just a rebuild. Right? Furthermore, as we're creating these 3D views, you have the option to capture, you basically rotate the part to the view you want to capture, give it a name, select any configurations you want to show. So this particular part has 4 different configurations, so we can show different versions of the model, and then select which annotation views you want to bring along. Right? And then we'll create our extra view. So in this view here, for example, we're looking at the part from the side, but it's a different configuration. It's a lighter weight version, right? So we get some dimensions of it there. So all this information is giving us the ability to really neatly compact all of our PMI, product manufacturing information, and all of our, design and manufacture and everything all into one file. So in this style, the model is king, right? And we're going to have drawings driven off of this, right? But let's go take a look at some more, right? So we've noticed that model-based definition is pretty quick and easy. You can see just there in a few clicks, I was able to begin dimensioning the model and get instant feedback on whether or not I had everything, right? So I had that error and dimension quality checking. I have all of my GD&T and PMI information. I got to organize all of my details, and I could even keep track of my legacy parts. So this new software is not going to invalidate my old data. And this is all really great to us. Well, now you might be saying to yourself, okay, Ben, you've introduced us to this new software. It's fantastic. But now everything is trapped in one SolidWorks part file. Well, what if my customers don't have SolidWorks, right? What can we do about this? SolidWorks model-based definition gives us the freedom to communicate. And actually, the 2014 and 2015 versions of SolidWorks already have the ability to create what's called a 3D PDF, where I can just simply save this part out into a PDF document that's 3D. So I can simply save this part out. It captures all of the face information, the geometry information of the part, and creates a PDF, an Adobe document that is openable, if you check it out here, by any Adobe reader and is pivotable, right? But we notice this doesn't have any dimensions on it. So how am I going to be able to create this part? Well, this is where SolidWorks model-based definition comes back in. All right. So we're going to keep you out of proprietary formats. Obviously, all your information is going to be on the SolidWorks side, but we're going to show you more about those 3D PDFs and the ability to communicate through them. Obviously, we're going to have to be able to make some customizable templates. That first sheet I created was kind of bland, right? Only one part on there. But model-based definition is going to give us that. And what's incredibly powerful is this ability to create interactive documents, so that it's not just a static sheet that everyone has to try and interpret the same way and maybe get different results out of. They're actually going to be able to turn this model over, look at it, interrogate it for results, and get all the information they're going to need out of it. So if we go back to our complete version here, where we've got all of our different views, right? What we're going to start looking at is our publishing tools across the top here. So notice it has eDrawings support, so if you're already using eDrawings in your manufacturing processes, you don't have to abandon that by taking up SolidWorks model-based definition, and in fact they work pretty well together. But what we're going to talk about today is the adaptation of this 3D PDF template editor. This is what model-based definition is going to get you over the additional, just the basic SolidWorks package, the ability to export to a 3D PDF. And so let's take a look at creating a template in the first place. Obviously, every time we need a template, we're just going to have to create it for the first time, then hopefully not have to mess with it ever again, right? Or at least not for a long time. Here's kind of a basic template that SolidWorks gives us, right? So what we're going to have is simple image blocks, right? That I can change the reference to and drop images onto. So in this case, we have a SolidWorks logo, right? This main area down here is going to be where we are interacting with the part. It's going to be the current view we're showing, and all the main controls there. Down across the bottom is going to be where we have those additional 3D views that we defined in the part. That's where they're going to be listed and selectable by the user of this 3D PDF. We have a BOM table area here, so any BOMs built into the part will drop into this location. But then in addition, we have the ability to insert different text blocks. So a text field, there's 4 different types. A text field is going to be a field that is editable by the user of SolidWorks creating the 3D PDF. And this is things like my name, any comments I have about this model, so on and so forth. They're not going to be editable once the PDF is created, all right? Taking a look at the next one, we have a template text field. The template text fields are values that you don't want anybody to change. This is only changeable from the editor. So someone using SolidWorks, someone using the 3D PDF, this is just static text, right? This is the equivalent to our 2D kind of our block area, where we kind of don't want people messing with this, right? We have our custom properties fields. So just like in our 2D drawings in SolidWorks, or even in our parts and assemblies, we have our custom properties built in, and we can reference those in these 3D PDFs so that just like our 2D drawings, these PDFs can automatically fill themselves out, right? So we can put in material, project dates, all kinds of things like that, just from creating the custom properties in the SolidWorks file. And lastly, this is part of that interactive capability. We have a PDF form field. So over here on the side, this text is interactable even if you only have the reader of Adobe PDF. This is like when you download forms off the internet and they have little fill-outable areas. So this is, in this case, it's being used as a comment field. I can send this document to a customer and they can inspect the model, turn it all over, measure it, do whatever they need to do, put comments on it and send it back to me so that we can have a running dialogue about this part, right? Just to take a look though at something that's a little more done up, I created this one for MCAD. So we can see here we've got an MCAD logo across the top, we have a comment area, the main model area, as well as the dimensions here. Now you notice I placed a background image across this one. Because of the fact that the main model area is going to take on whatever background color the SolidWorks part itself had, which is generally white for us SolidWorks users, right? You can actually put like a background image on this, and it's not going to interfere with your ability to read the model, so you can kind of create a little more fancy document if that's what you're into. And notice here I've also placed a note, and this is in the template text, right? So it's not editable by the users. These are the dimensioning standards that MCAD as the machine shop applies to everything, or whatever standards you want to apply. You can apply them here, or you'll see we can actually put them in the part as well. And I have some custom property field fillers as well as some text area fillers as well. So that's great. I can save this out. Just as a note to the users, 3D PDF templates are not one monolithic file. They're actually a file folder full of pictures and things. Just keep that whole thing together. Treat it like it's one file. You'll be fine. Just be aware of that. But what we're going to do is we have our part all done up with our 3D views. Now we're ready to publish. So we're going to publish this to a 3D PDF. And we can see here we can select our different themes. Just like document templates that we have set up for SolidWorks normally, we can go to our file locations and add different folders to create these references here. So I have my MCAD template. I have a picture to show me which one I'm using, which is handy, right? And I select which annotation views I want to include. And then in my output details, I can define the file name or its location, right? So let's put this one on the desktop. And I already have one of these, so we'll just go ahead and call it complete 2. Why not? Completely technical name, right? And I can come down here, and this is where those text fields come in. So I can hit this, and it has each one. So I say, okay, this is our Tech Days online presentation, and that this was me creating it. So I can fill out those fields there as a SolidWorks user. Again, that's that particular text field type that's only editable from SolidWorks and the editor, right? And then lastly, I can come down here and fill in my custom property fields, so I can add in a part number, right? And a weight. I've already got my material and my date applied, right? So this all looks good. I'm going to view the PDF after saving. And what I'll go ahead and do is export this, and you're going to see in the background, if you've ever used the SolidWorks simulation report generator, which will generate kind of pre-scripted Word reports of all of your results. If you've watched it go, it kind of pivots the part and takes pictures in the background. So that's what it's doing right now. Is in the background, it's going to be capturing all those different 3D views, all of the geometry information of the SolidWorks part, and generating that 3D PDF file in the format that we created in our PDF editor. Right? One of the advantages to these 3D PDFs while this is creating is that they're incredibly lightweight compared to the part. So these 3D PDFs, SolidWorks Model-Based Definition, works with assemblies as well. And these PDFs are easily emailable, so that the size is not going to be as much of an issue. So we can see here I can pivot the different models, I can select the different 3D views we had, and the dimensions are all visible, right? But I can pivot the model to make sure I can check a particular value. Now the interface is a little bit different to deal with. It was developed by Adobe in 2013, which is what drove a lot of this development. So if you're used to SolidWorks, it may be a little different, but there you go. Here, this note was actually placed in the SolidWorks part file itself, so we have kind of a carbon copy of any dimensioning values, tolerancing values we want to create. I can pivot to my top view, and this is just like it would be in the 2D drawing, right? I can come up here and say, okay, well, let's actually have, solid wireframe showing, or I want to show, a solid outline of the parts. There's some different ways of being able to display your parts. I can see a bounding box of the overall size, right? And I can see all these dimensions, but of course the advantage of this 3D PDF is that I can still pivot the model and take a look at exactly where those dimensions are pivoted, right? Or where they're attached. Further, let's say I come over here to the front view, right? Taking a look at, again, different dimensions. Maybe I happen to be looking at this, or I look at the right view, and I see that, okay, well, there's a lot of dimensions on there, but looks like there's one kind of missing. So we can take advantage of the interactive qualities of the 3D PDF for this. First and foremost being the 3D measurement tool. So I can click on this, it snaps to geometry if you want it to, and so I can very quickly measure between two different holes and get a 3D value, right? Get the exact value. You can see it reports down here on the bottom as well. And I could also place a 3D comment on this feature and say, these holes, hole distance is too small, right? Increase to 25. So that 3D comment would be added, right? And I could move it if I needed to. But what's going to also be powerful about this is the fact that once you turn off your comment tool here or hit escape to get out of it, you can pivot the model, and that 3D comment is still going to be attached to the same piece of geometry. And so I'm still going to be able to see, read, and interrogate, and look and see what exactly is this piece being attached to, right? And like I said, up here we have our PDF comment field. See attached comments to model, right? Something along those lines. This is all in Adobe PDF. This is outside of SolidWorks. So this is not proprietary to any particular group. Anybody can read this. By the way, if you're concerned about, if you're thinking and you're concerned about your intellectual property, you don't want customers to be able to measure specific values, what you can do is place the values you want to show as dimensions from the DIM expert, and then while you're creating this PDF, going through your PDF options, you can secure this document, which is just a set of the PDF options, and this interactability will go away. So the document will have the dimensions, have this kind of template function, but they won't be able to pull everything out of it. All right. And last but not least, one of my favorite features here is the 3D PDF tool actually has its own cross-sectional tool. Now again, this was developed by Adobe and not by SolidWorks, so the interaction is different. But in a similar fashion, we can pivot to a certain particular point on the model and see a cross-section. So maybe I want to see what the inside of these holes look like, and I can take a look and zoom in on that. This is all in Adobe. This is all doable on an iPad or at a workstation inside your machine shop. And these are highly mobile documents. So again, SolidWorks model-based definition gives us the freedom to communicate with those universal file formats, neatly organized information, and now we don't have to translate. Going back and forth between 3D to 2D to 3D is just like trying to go back and forth between English to German to English, right? You're going to lose something every time unless you're really careful. And so there's no longer interpretation. This is just direct reading. universal file formats, interactive documents, custom templates to show everything you need to show. All right, Ben. This is so fancy. I'm excited. When will I absolutely have to have it? Maybe not today, but soon. All right, SolidWorks did a study in 2009 of its customers and found that, only a few were interested in this kind of technology. But as you can see, 2013 was the big watershed moment, all right? Adobe came out with this 3D PDF format, as well as the DoD doing some research on this that we'll talk about in a minute, finding that model-based definition is the thing they want to do. So industry standards have already started to pick up model-based definition. MilSpec 31000A Appendix B has the new specs laid out for what the military is going to expect as far as model-based definition processes. Again, model-based definition is the name of this 3D definition process and also the SolidWorks product, but you're going to see similar products coming out from all the other major CAD vendors. SolidWorks just got the jump on it. Like I said, so MilSpec 31000A, ASME 1441, ISO, DIN ISO, GBT, everybody's jumping on board with it. And MBD will be mandatory for the DoD branches by 2028, and obviously their supply chains are going to favor anyone who can support MBD. So if you're at all in the military supply chain, you got to be looking at this technology. It's coming sooner or later, right? But you will be seeing it. So right now, here in 2015, we're in this early adopter phase, this early majority, right? Jump on board, save yourself some money, and jump in on the future. So in addition, I just want to mention it's an emerging practice, MBD is. So some of those standards may not yet have definitions for your specific industry, but keep an eye on it. They will be coming soon, and maybe you could be the person to help create those. So let's talk about who is currently using MBD and what they're getting out of it, right? So I already mentioned the Department of Defense. They're kind of the main pushers behind this. GE Oil and Gas, so large energy sector customer. Like I said, any DoD supply services, right? Defense contracting, custom furniture, or anything as varied as custom package handling, JPL, Disney, Baker Hughes. Lots of different groups are looking at this technology for those cost savings and for that speed increase and for that loss of the need to translate back and forth between 2D drawings, right? So it's a hot topic right now. Primarily though, SolidWorks sees the major adopters at the moment being government contractors, aerospace, automobiles, consumer goods, industrial equipment, that sort of industry, right? And obviously, if you're using an older machine shop or your machines, don't necessarily have computer screens or iPads or things like that, then this technology is not going to be quite ready for adoption for you. But, like I said, as it's coming down the road, this may be an adaptation you need to make as you're going forward. So let's get back to why SolidWorks model-based definition specifically. Well, Rick Eichenrode, who's the co-chairman of the subcommittee that wrote the rules for MilSpec, right, on model-based definition processes, says that SolidWorks model-based definitions compliance to MilSpec 31000A Appendix B is close to 100%. SolidWorks model-based definition's ability to achieve a highly compliant MBD model viewing schema is as good as or even better than other CAD systems. Great plug for us there. But what the real takeaway there is that SolidWorks is highly invested in making sure that this is going to be able to be compliant for your systems and usable, right? Obviously, they don't want to try and sell you something that you are going to have, it's going to be useless, right? They want it to be useful. You're going to get your money's worth out of it. The real idea is we're getting our ideas out faster. We're getting the edge on innovation. We're having confidence, and we're minimizing expenses by reducing all that rework, right? Fixing those leaks in our model. And Brian Truly with GE Oil and Gas, who I mentioned was another customer of MBD, says that with SolidWorks model-based definition, the 3D model itself holds all the dimensional data necessary to make the part. This means less documentation creation, fewer emails flying around, and fewer files to sustain when the project is complete. Really just saying this is easier in general. It's a new process, certainly, but once you get on board with it, man, is it fast. And furthermore, data quotes I don't have directly here, some of the model-based definition lighthouse customers, so those who were testing the software just to see kind of what capability was there, found savings in their drawing and rework departments of up to 30 or 40%. In fact, the military study that was conducted on model-based definition that convinced the DoD that this was something they needed to do found that on the particular base they were working with, they got 20% savings in their drawings department. So even if you only touch half that value, 10, 15, 20%, this is still an incredible opportunity to reduce those leaks in your business model and really get some more cash flow going, right? So if you have any questions about SolidWorks model-based definition or would like to see a demonstration, either by web or in person, feel free to contact us. Go to MCAD.com or email me, benjamin@mcad.com, and we'll be happy to give you some more information about model-based definition. I also strongly encourage you, if you're interested in this technology, to check out the 2016 release when we get the professional and premium versions of model-based definition as well, which I'm sure are going to include all kinds of great doodads for us to be able to further be able to lock down our parts and get a lot of functionality out of this software. So like I said, my name is Benjamin Collins. Thank you for listening, and we'll see you next time.